Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at quantiles and the normal distribution. So quantiles occur when you divide the data into equal groups. If we divide into 4 equal groups, we call them quartiles. You would have learned that when we did box plots. 100 equal groups, we call them percentiles, and so on. We're doing something a little more sophisticated though. We're actually doing the opposite or the inverse of what we did in the previous lesson. So in the previous lesson, we'd get a score from a normal distribution and we'd find the probability of getting something less than or greater than that score. But now we're doing the opposite. We're going to start by knowing the probability and we're going to find the associated score required to yield that probability. So the function required for this lesson, you press second and vast to bring up the distribution menu, and option 3 is the inverse normal function. So you do that when you're trying to find a score already knowing the probability. So when you call this function, you'll see that the first thing you need to input is area. So what's that all about? So here we have a normal distribution graph. Now, because it's a valid probability distribution, we know that the area under this curve is equal to 1. So what we're doing here is we're finding a value k so that the area here is some specified value. So if we look at the first question here, we're saying we have a score from a normal distribution. The mean is 7, the variance is 9, so the standard deviation is the square root of that, the standard deviation is 3. We want to find this value k so that the area before k is equal to 0.67. So there's no way that we could do this in our head, but we know because the area is more than 0.5, more than 50%, this value k must be more than the mean. So how we figure out this value k is by using the inverse normal function. So when it asks for the area, we put in 0.67. That's what we want the area to be here. And then we just put the mean is 7 and you put the standard deviation of 3. So we put it in our calculator like this, area or probability that you started with, mean, standard deviation, and it gives us the score 8.32. So this score here must be 8.32. So that means if you have a normal distribution, mean 7, standard deviation of 3, the probability you get a score less than 8.32 is equal to 0.67. So now let's look at finding the value of the score so that the probability of being greater than that score is 0.74. So this one is a little tricky because of the inverse normal function. It only allows us to input the area that is less than the value that we're trying to find. In this case, we know the area that is greater than the value that we're trying to find. So we need to do a bit of manipulation first. So if the probability that x is greater than k is 0.74, which is greater than 0.5, we expect k is going to be less than the mean. So k is going to be down here. The reason is that we know the area greater than the mean is 0.5, so then this area here will be 0.74. So if the area greater than k is 0.74, then of course the area less than k down here must be 0.26. So we put inverse normal, the area is 0.26. We always put the area less than the value that we're trying to find. So the answer that it gives us is 5.07. So that means if the data is normally distributed with mean 7, standard deviation 3, then 74% of scores are above 5.07. All right, let's try this one here. So this one is tricky because the inverse normal function certainly doesn't allow us to put in a range. So what we're going to do is draw this and use our knowledge of the symmetry of the normal distribution. So we have something that looks like this, and this area between 7 minus k and 7 plus k is equal to 0.32. Now note, 7 minus k and 7 plus k are the same distance from the mean of 7. So because of the symmetry of the normal distribution, there'll be 16% of scores in each of these areas. So the problem is the inverse normal function only works when we know the area less than the value we're interested in. But I know that 50% of scores are less than the mean of 7. So if 16% of scores are within here, in this area over here must be 34% of scores. So the probability of being less than 7 minus k is 0.34. Now I have everything I need to use the inverse normal function. So if I put inverse normal 0.34 and then the mean and standard deviation, I get about 5.76. So this isn't the value of k. I've found that 7 minus k equals 5.76. So solving that really simply, k would equal 1.24. All right, let's now do a worded problem on this. So let's try this one here. A company makes tablets. The amount of active ingredients in each tablet is normally distributed, mean 20 milligrams, variance 25 milligrams. So the lowest 5% and highest 10% of concentrations of this active ingredient are rejected. We're going to find the range of acceptable amounts. So what we're going to do is let X be the amount of this active ingredient. And we're told from the question that X is normally distributed with mean 20, variance 25. So of course that means the standard deviation is 5. So we have a normal distribution like this. Now at some point over here, the lowest 5% are rejected, and at some point over here, the highest 10% are rejected. We need to find the value here and the value here. That will tell us the range of acceptable values. So let's start by finding k. So what we're saying here, the probability of being less than k is just 5% or 0.05. So we know how to do this. We're just going to use the inverse normal function. So putting this in our calculator, we get about 11.8, and it's measured in milligrams. So what we've found is if the quantity is normally distributed with mean 20, standard deviation 5, 5% of the tablets will have 11.8 or fewer milligrams in them. So now let's find m. So the probability X is greater than m is 0.1. But remember, we can only use the inverse normal when we know the area or probability of being less than that. So the probability of being less than m will be 0.9. So again, we're just going to use the inverse normal function. So putting this in our calculator, we get about 26.4 milligrams. So the acceptable range is 11.8 to 26.4 milligrams. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.